All right, thank you and good morning. And thank you again for coming to reInvent. It's great to see all of you in the audience this early on a Friday morning after a great party last night, but thank you very much for coming. I'm Kevin Miller. I'm one of the engineering managers within the EC2 networking team. And so my team is responsible for services like Virtual Private Cloud, our VPN service, and our Direct Connect service. And today I'm going to do a deep dive on Amazon Virtual Private Cloud and hope to address some of the deeper questions you might have. So without further ado, we'll just get going. So we've had several presentations at reInvent that talk about Virtual Private Cloud and different parts of the networking stack within Amazon. I just have a couple references. I think these have all happened already, so if you haven't attended them, look for the audio or the slides afterwards. And if I don't answer your question here, I suspect one of these others may. We have a lot of good content here this week on Virtual Private Cloud and some of our networking services. All right, we're going to cover three things today. So first is going to be routing and private connections. We're going to do a deep dive on how customers think about using Virtual Private Cloud, particularly in a hybrid IT architecture where you have maybe some existing infrastructure off-premise and then looking to expand into VPC. So we're going to talk about that. We're going to talk about VPC peering, which is a feature that we launched in March of this year. We're very excited about this. This is a feature that allows you to connect VPCs together with a highly available, high-capacity interconnection, and is great for some use cases where you have multiple applications or multiple business units. So we'll talk about that. And then finally, I'm very happy to talk about the last section, which will be related to customers who have existing EC2 Classic infrastructure. We know many of our customers have significant Classic infrastructure and are looking for a path to VPC. They see VPC, they see that we've been adding features to this over the last several years and would really like to adopt VPC. And we have a feature that I'm going to talk about today, which we believe will help you do that, and we'll deep dive on that as well. So that's what we're going to cover today. All right, so just to level set on some terminology before we dive right in, we have two networking stacks within EC2. On the left, we talk about our EC2 Classic networking stack, and VPC is the other on the right. So when we launched EC2 back in several years ago, the networking experience was a very simple networking stack. We made it simple to get started. Every single instance has a public IP address that's automatically assigned by Amazon. We also automatically assign the private IP address. And we give you control over security through security groups. So you can use security group rules to restrict access to your instances. Then in 2009, we introduced VPC, and we've been adding features to it over the last several years. VPC gives you the ability to do much more deep security controls, as well as some of the popular networking features that customers have asked for over time. So that includes things like multiple network interfaces, multiple IP addresses on an interface, which customers use for SSL hosting and applications like that. Routing tables to do some more advanced topology that we'll actually deep dive on a bit here today. Network ACLs, private connectivity through our VPN service. And then last year, we launched our enhanced networking service with VPC. And if you haven't used enhanced networking, there was actually a talk yesterday, or rather Wednesday, that really dove deep on enhanced networking. But it really is a significant increase in packet rate performance on EC2 and within VPC. And we're really excited to share that. And customers are responding very positively to that. So that's our VPC networking stack. And then last year, we completed work on what we call our default VPC. And so all accounts that have been created with AWS since last year, since 12.4 of last year, are actually operating in VPC in this default VPC mode. And so what we tried to do with default VPC was really combine the best of these two worlds. So with default VPC, you get started using the Classic experience. Instances receive public IPs by default. We take care of the private IP addressing. But you have the flexibility to start using any of the VPC features at your own pace. So at a point where you are interested in beginning to use VPC, then you can start turning those features on. So we just launched our region in Germany a few weeks ago, and actually every account there is operating in a default VPC. So again, with default VPC, you can get started with the Classic experience, use VPC features, but you also can create your own VPCs. You know, if you have an architecture where you're all in with VPC and you use it for everything you do, you can create as many VPCs as you want, you know, in those default VPC accounts. So that's kind of the background on some of the terminology. If you are curious, you know, what your account is set up for in a particular region, there's actually a way to interrogate the APIs. And throughout the day, I'm going to use the AWS CLI tools to provide examples, but most, if not all, of these features are available in the AWS Management Console as well. So using the CLI tools, we can run this command and just confirm if we have a default VPC. If so, that will be shown here as an attribute, as well as the supported platforms. And so if I was a EC2 Classic customer, my supported platforms would show both VPC and EC2. All right, so we're going to now start to deep dive on routing and private connections and talk through some of the advanced capabilities of VPC. So customers often come to us and say, you know, I have some existing infrastructure either in a co-location facility or maybe my own data center, and I'd like to get started using VPC. I'd like to build a hybrid architecture, and how do I do that, and what does it take? So we'll start with you know, just that you know, you start with some servers or some infrastructure running somewhere outside of AWS. The first thing you can do is create a VPC, and again, I'm going to show the commands to do everything that I'm showing pictorially here today. But you know, with 3 commands, you can create a VPC. You can create a couple subnets. In this case, I've created a subnet in 2 availability zones, and I can continue forward from there. The next thing I'm going to do, again, if I'm looking for a hybrid architecture where my existing infrastructure, my data center works with my VPC, the next thing I'm going to do is create a VPN connectivity to my VPC. And so again, with a series of a few APIs, I can create the objects that I need. I create what we call the virtual private gateway, which is the lock icon there. And then create a customer gateway, basically identifying the router that's going to be on my infrastructure, at my perimeter. And then create a VPN connection between the 2. Now, once you create a VPN connection, we provide configuration guidance for a variety of routing devices, VPN routers that you'd have at the edge of your network. So I think today we have something like 14 different devices that we provide configuration guidance for. But all of these VPN connections are built on industry standard IPsec technology. And so customers have identified, you know, beyond the 14 that we give guidance for, customers have found that it works and interoperates with other devices as well. And we provide all the details about how to configure that. But if you are using one of the devices we provide the guidance for, you can, in most cases, sort of copy and paste a set of routing instructions and apply them to your device to get a VPN connection established. So from here, I'm going to go ahead and launch a few instances in my subnets. And again, kind of the simplest possible way to launch some instances, I just specify the machine image I want. I specify the subnet IDs, as well as, you know, you can actually launch multiple instances in one API call. Now, this is the key difference between a run instances call. If you're an EC2 Classic customer and you're looking to use VPC, this really is the key difference between a run instance call for Classic and a run instance call for VPC, is that you specify the subnet. So that's how you identify that I'm going to launch this into a particular VPC, a particular subnet. And if you're not familiar with VPC, subnets are AZ specific, so each subnet resides in a single AZ. So obviously we do recommend a multi-AZ architecture and using multiple subnets, therefore, to have instances in multiple availability zones. Now, another thing you can do with this architecture is use AWS Direct Connect. And so our VPN service is IPsec VPN over the internet. Direct Connect actually allows you to establish a dedicated circuit from your edge of your network into the AWS cloud. And we support connection rates of 50 megabits per second all the way up to multiples of 10 gigabits per second that you can use over a Direct Connect link. Now, Direct Connect has a physical element to it, so I am showing the APIs. Actually, all of the configuration that you do on Direct Connect on the Amazon side is actually done through APIs. It's self-service. and we have a management console for this, although there is a physical interconnect that is then created. So for example, if you have an existing infrastructure, an existing cage in one of the 14 direct connect locations we have around the world, this physical process takes typically about 24 hours or less to get established, and then you can have a direct connect link into our cloud. If you don't have a presence at one of those co-location facilities, we have a list of partners, I believe more than 50 partners today, that can help you get connected from wherever you are into one of our 14 locations. So again, I'm showing the commands here that you can use to create a direct connect connection. And in this case, you can have both direct connect and VPN operating in parallel through the same virtual private gateway. And the way that this typically works is that direct connect would be the primary link, and you could have a VPN failover as a backup to direct connect, or not. You could have a dedicated, direct connect only. All right. So when you create a VPC, every VPC has a default routing table, and every subnet will use that routing table. And so I've created some connectivity here. The last thing I need to do is literally just put a route into my routing table. And in this case, I'm just going to say I want all traffic coming out of my VPC to go through my virtual private gateway, basically to go back to my data center. And I configure that. And once I do that, now I actually have full end-to-end connectivity. My corporate data center can talk to my VPC and back. My VPC is an isolated box, so as I'm showing it here, there's no connectivity to the internet. There's no connectivity anywhere except back through my virtual private gateway to my home data center. But now we have the ability to implement a hybrid architecture where I'm scaling out into the AWS cloud, or even moving applications from my data center to the cloud. All right, now I want to do a brief segue into talk about remote connectivity best practices. And so some of our customers, when they're building hybrid architectures, they come to us and say, hey, I'm going to have a pretty hard dependency on AWS, where every single request that I receive is going to have to transit the connection between my data center to AWS and back. So it's a real-time ongoing dependency. And so we talk about, when we hear those kinds of requests, we talk about the availability patterns that we see. So a good availability pattern that we recommend is to use our VPN service with a BGP routing protocol across those links. And every VPN connection is actually implemented as a pair of IPsec tunnels. So when you create a VPN connection, you'll be given all of the information to connect two IPsec tunnels to two independent availability zones. And this provides good availability if you set up and configure both of the IPsec tunnels. Now, you don't have to use BGP. You can actually do this with static routing. But again, for customers who are building architectures with a tight coupling between their data center and AWS, we strongly recommend the use of BGP here. We give you the configuration instructions to set this up. Some customers have never used BGP before, but typically report that once they have those exact commands that we provide, it's fairly easy to get this set up and working. Now, this is a situation, if this is set up as it's shown, if and when there's a failure on one of the devices, one of the VPN endpoints within AWS, traffic is automatically rerouted to the alternate IPsec tunnel. So that maintains your availability. The next conversation we typically have with those customers is about improving the availability of the devices at the customer end. And so a better availability story here would be to actually create two VPN connections and to create that from two routers at the edge of your network. So some of our customers may have multiple data centers or multiple facilities, and they would create these connections from routers in different data centers. So this will end up being a total of 4 BGP tunnels, 4 IPsec tunnels rather, with BGP running across them. And in this case, if any of the 4 devices on this slide fail, traffic is going to be automatically rerouted through the alternate device. So this provides a better availability story. Finally, for customers that have very stringent requirements or the highest requirements about availability, we typically recommend that they investigate the use of AWS Direct Connect. Direct Connect provides circuits and pathways outside of the internet. It's dedicated between customer site and AWS to improve the consistency of the network performance. And in this case, I'm showing two direct connect connections. Those are the blue links, two direct connect connections from different routers at the customer site to different direct connect routers within AWS, and then also using VPN as a backup. And I think this provides the best availability story for that connectivity between your site and AWS. And again, if you are building an application where you have real-time service communication across these links, we definitely recommend you build the best availability story that you can. Now, a couple other details about this, just to be clear. Direct connect connections are point-to-point connections, single connections. So in this case, you'd be creating two direct connect connections. And each of our 14 direct connect locations offers a pair of routers. So in any of our locations around the world, you can bring two connections in, and they'll land on physically diverse gear within our facility. Also, some of our regions actually have not just two routers within a single facility, but we have multiple facilities. So for example, with our US East 1 region, you can connect both in New York as well as in Ashburn, Virginia, and have direct connect links that are physically diverse as well as hardware diverse. All right, so now we're going to continue to evolve this picture that we started with a little bit ago. We're going to continue to evolve it, and we're going to add internet connectivity to it. So customers sometimes typically will build a hybrid architecture. They may start with private connectivity only, but then look to add public connectivity at some point down the road. So by adding public connectivity here, to do that, we create an internet gateway and attach it to our VPC. And then we're going to remove, previously we had set up a default route that just pointed home to our home data center. Now we're going to remove that route and point the default out the internet gateway and create a more specific route that points back at our home network. So for example, in this case, I'm showing our corporate data center, maybe 192.168, and we're going to point that back. We're going to point all the traffic destined for that prefix back to our data center and default pointing out to the internet. All right. And I also want to just underscore, for customers who aren't familiar with VPC, the Internet Gateway is a high-capacity, highly available service. There's no inherent single point of failure within the Internet Gateway. So you don't have to be concerned about capacity constraints there. And functionally, it is very similar to what we provide in our EC2 Classic environment. So the Internet Gateway introduces no additional latency or throughput constraints beyond what customers may see in EC2 Classic today. Okay. Now, one additional capability that we have that sometimes customers use to simplify their routing tables is what we call route propagation. And this is a feature where we will automatically listen to the routes that you're advertising to us through BGP, and we will insert those into your VPC routing table for you. And this is a pretty simple feature to configure. In this case, I'm just showing that we are going to delete that route, that static route that I just created. And then I'm going to enable route propagation, where I just have to specify the routing table that I want this routes to be propagated into, and then we'll start propagating those routes for you. So this is useful if you have, some customers will use MPLS. They'll have an MPLS cloud, which they can then connect through direct connect to our cloud, cloud to cloud, so to speak. And the MPLS, over their MPLS cloud, they will dynamically advertise prefixes when maybe a new office comes online or a new data center. And with route propagation, then there's no additional work required when that site comes online. The site comes online, and then the route gets propagated through. All right. Another feature that we have in VPC is the ability to create multiple routing tables. So every single subnet in VPC has a routing table that it uses to make all forwarding decisions. By default, we create a single routing table, and all of the subnets will use that routing table. But here we're showing that we can create a new subnet and a new routing table, and we're going to associate those two together. And now all of the forwarding decisions coming out of my new subnet, this 1010.3, is going to use this new routing table. And the new routing table, in this case, we're going to basically configure this routing table to send all traffic to the internet. But there will be no routes from our VPN or direct connect connection. So in this case, my 10.10.3 subnet will be a public-only subnet. These instances in this subnet will only have connectivity to the internet. They won't see a route to the home data center. So sometimes customers will use this for example, their web, something that's web-facing or purely internet-facing, where they don't want it to have any connectivity to the home network. So one of the things that our customers have done over, as we've introduced VPC and we've scaled out in multiple regions, we've seen a pattern where customers are looking to connect multiple VPCs together. Sometimes, most commonly today, this would occur across multiple regions, where a customer has instances in multiple regions, and they'd like their they'd like to have private communication between those VPCs. And so today, the way that we see customers solving this is to use some sort of software VPN capability. So they'll launch this as an instance and configure routes in the routing tables for for those subnets to direct traffic to the remote VPC, through this VPN instance. And so the VPN instances here will have the connectivity between them, and we will create routes in the routing table. One other thing I want to highlight on this slide is that you'll see in the commands, the first command is modify network interface attribute. These commands, so what this is doing is turning off what we call the source dest check. So typically, as a security mechanism, every single instance will, in the substrate, in the hypervisor, we are inspecting every single packet and making sure that it's either, when packets coming from the instance are coming from one of the source IPs that are assigned to that instance, and vice versa. When a packet's about to be delivered to the instance, we look at it and check to make sure that it is destined for an IP address in the instance. And when you have a software VPN like this, you need to have connectivity. You need to actually turn that off so that packets can be sent to the VPN and then forwarded on to the remote site. So we turn that software dest check off. And then in this case, we are allowing the 10.10.1 subnet and the 10.20.1 subnet to communicate through these VPN instances in the other subnets. And so moving on, another use case that we have, or another situation that we see customers sometimes configure is a case where they are looking to have some sort of NAT or firewall between their traffic and the internet. And so customers are able to do this as well using the multiple routing tables and multiple subnets. In this case, we have a NAT or firewall instance, and we create a new routing table. The routing table for the subnet with the NAT or firewall instance sends traffic straight to the internet. The routes for the other subnet send all of that traffic to the instance ID. In this case, the instance ID would be the instance ID of the NAT or firewall instance. All right, so that was kind of a deep dive on some of the routing features we have in VPC. And I mentioned that some of our customers use software VPN to connect two VPCs together. And we saw this as a pattern that was happening quite a bit. And so that's what inspired us to go look at building a feature that would solve this problem for customers. And so that's VPC peering. Again, so we built this and launched this in March. VPC peering provides a high-capacity, highly available path between two VPCs in the same region. So when I talked about the software VPN, I mentioned multi-region. We definitely still see customers that are building software VPN for that multi-region capability. But within the region, we've solved that with VPC peering. So VPC peering is basically two VPCs that are going to be connected together. We have a handshake protocol that's required. So you have to create a peering connection, and then the other VPC has to accept the peering connection. And that's partially because we actually allow this to occur across accounts. So you can actually create a VPC peering connection with a separate account. When you do that, the peering connection request, you do have to specify the peer account ID. And then again, the other account owner has to accept that peering connection to ensure that it's authorized. And I should note as well, I forgot to mention it earlier, but all of the commands that I'm running today can be locked down with IAM policy. So typically we see customers build an IAM group that for network engineers or sort of infrastructure engineers that are authorized to make some of these fundamental infrastructure changes, and then create separate groups with permissions to run instances or do other operations, but not some of these fundamental operations. So again, every single command you've seen here today can be controlled with IAM policy. So with VPC peering, I go ahead and I create my peering connection. I accept it, and then I create routes in both of the respective routing tables to direct traffic through the peering connection to reach the other VPC. Now, the VPCs for peering have to be separate IP ranges. They cannot overlap. You cannot peer with something that overlaps with yourself. However, VPC-A could actually peer with multiple VPCs in the 10.20 address range. So we do allow that. And then you would just use routing tables to direct traffic to one or the other VPC, depending on what your interests are. All right, a couple just considerations to be aware of around VPC peering. Today we don't support security groups across our VPC peering connections. The workaround for this is that you can specify rules by site address in your network ACLs or your security groups. We also don't currently support what we call a transit capability or a transit VPC, where you would come in via VPN to one VPC and then have a peering connection to the other. So right now, VPC peering is just for instances in the two VPCs to be able to communicate between each other. And then I mentioned the peer address range on the previous slide. Some of the common patterns we see for VPC peering, one of my favorite is what I call the shared services model. So we hear from customers a lot that they have some common needs like authentication, monitoring, logging, et cetera, and they want that to be centralized in one VPC. But then they want to build separate VPCs that are maybe done at the business unit level or sort of a group of like applications that are working together in one VPC. So this is, I think, a great model for that, where you can create, in this case, like VPC-A is at the center of the world. That's your shared services VPC, and then have other VPCs that peer in with that. Again, this would all be within the same region. Another use case that we see customers talk about, particularly with VPC, is to have identical VPCs for dev, test, and prod. And again, you can have, they can be identical down to the IP addressing and the subnets and the rules, so that you know that what you're building in dev or test is exactly what you're going to deploy in prod, from the network infrastructure standpoint. And then you can use peering to gain access to those VPCs or to monitor or maintain those different environments. And then finally, we talked a few previous slides ago about the use of a VPN or a NAT or a firewall device going out to the internet. Similarly, you can do the same thing with VPC peering. So you can create a NAT or firewall that would direct, so any traffic that's going to the peer VPC would be directed through this NAT or firewalling instance. Again, you would use multiple routing tables to do that. We show the commands here, as well as from the previous slides. But this would allow you to put something in the middle of this that would inspect all of this traffic. Okay, so that was a quick review of the VPC peering feature. And unfortunately, I can't take questions now, but I will absolutely take questions afterwards. We are now going to talk about how EC2 Classic customers can think about adopting VPC and some of the patterns we see there, as well as a new feature that's coming. So in general, we're hearing from a lot of customers saying, hey, I like the things I'm hearing about VPC. There's a lot of good stuff there, but I don't know how to get started. And I have a lot of classic infrastructure that I have, and I need to maintain that, and I can't move that without a plan. So the first recommendation we have is to start simple. The simplest VPC is I've sort of depicted a very simple VPC up here with it's the VPC. It has an internet gateway, and then we have one subnet in each availability zone. And so we also have a flag that you can set on the subnets, and each of those subnets can then be configured to automatically assign public IP addresses when you launch instances into the subnet. So setting this kind of simple VPC up, you will have an experience that is identical, or very close to, I shouldn't say identical, but very close to Classic. It is basically what we do with our default VPC capability. Every instance would have a public IP address. It will have internet connectivity, and then you can use security groups to control access as you would in Classic. Then, over time, as you need features in VPC, you can start to take advantage of them at your own pace. So we have a lot of advanced networking capabilities in VPC. You don't need to use all of it. I don't know that anyone uses all of it, but there are features that individual customers find helpful for their environments. Maybe it's multiple interfaces on the instance or multiple IP addresses. It could be the private connectivity we talked about, or enhanced networking. T2 instances, for example, is another popular one that we're hearing about. So again, you can adopt these kind of at your own pace based on what you need. Now, For customers that have a significant Classic workload, they ask, how do I get these Classic instances and applications moved into VPC? Today, we've seen a couple patterns, sort of a big bang versus an incremental, and I'll share some examples of that. And I have something new to talk about as well that we believe will help customers migrate from Classic to VPC. So the Big Bang approach, I've shown here a sort of a simple topology where I have a load balancer and some instances running in Classic. Essentially what I do is I'll create a new VPC, I'll create the security groups, very similar to what we just talked about in terms of a simple VPC. I will then snapshot my instances and any EBS storage, and then I will recreate those in VPC. And then I'll recreate and reconfigure these and launch these as relaunch these as my application. And then once I'm done with that, I can, of course, turn off the old Classic instances and be completed. So a Big Bang approach involves really thinking through the plan, preparing for it, ultimately shutting down the instances in Classic, building the AMIs, the snapshots, and then relaunching them in VPC, and finally reconfiguring them and having them work in VPC. Now you can really dry run all of this, so you can do this without touching your Classic environment to get very confident in the final VPC configuration. But ultimately, with a Big Bang type of approach, at the point that you shut down or stop your Classic instances, that will create an availability event for you. So there will, we'd recommend a maintenance window to perform that operation. I think the benefits of this are it's fairly straightforward. If you have a small number of instances, this may be the simplest possible way to move. You also can have a fairly clear rollback strategy. If you stop the instances in Classic and something isn't working in VPC, you can restart the instances and then figure out what happened offline and retry it. The second type of approach we're hearing from customers that the customers are doing is more of an incremental approach, or they're looking to migrate one component of their infrastructure at a time. So in an incremental adoption approach, if we assume that we have, for example, a Route 53 DNS name pointed at an Elastic Load Balancer, in this case, you could start to move individual tiers of your application. In this case, perhaps move some of the web servers, the front-end web servers, have those talk to a back end that's still running in Classic. And then over time, you can turn off the Classic turn off the Classic web servers, and then migrate the back end into VPC as well, using similar techniques to what we described with the Big Bang approach. So the benefits of an incremental adoption, it is component by component. You don't have to think about your entire architecture in one shot. You can really prepare each component, build a new copy of it in VPC, and then reconfigure those components as you move. We do believe this results in shorter maintenance windows. Probably the biggest challenge with this that customers face is that per component is the last bullet on the cons section, which is it does require per component integration, which is to say this is all done via public IP communication. So we don't have a capability today to integrate security groups between VPC and Classic. So if you do follow this incremental adoption approach as we've identified it, this would require public IP communication that you would authorize on your instances. So we're hearing from customers that they want to move, they want an incremental adoption approach, they want to be able to do this without a big maintenance window or have a large amount of downtime, which is absolutely the expectation for modern services. And then don't want to have public IP communication. They want private IP communication, and they want security groups that span Classic and VPC. And so I am pleased to share a feature called VPC-ClassicLink. VPC-ClassicLink will deliver all of the things that I just described, and I'm going to share with you how that will work. VPC-ClassicLink, by the way, is going to be available in December. So with ClassicLink, again, we're going to we start with a fairly typical architecture that we see. Here we have an Elastic Load Balancer with maybe some front-end web servers and a database. Using Route 53, for example, to direct DNS traffic at the load balancer, although you could use other DNS providers. This is not exclusive to Route 53. We're going to go ahead and create our VPC, just as we've done with the prior examples. This is some of the magic here that will be available with ClassicLink. So here I'm showing a security group. This is a VPC security group. And you will be able to have Classic instances join the VPC security group. So you will create this, again, create this as a VPC security group, and then using the ClassicLink capabilities, you'll be able to associate Classic instances with that VPC security group. As a first step in the migration, we would suggest moving AWS managed infrastructure, and I'll share, I have a slide that shows that in a little bit more detail, but RDS databases, for example, would be something I would suggest moving early. And once you move this is again the kind of the key capability we have here with ClassicLink, is that the Classic instances will be able to communicate with the RDS database running in your VPC using private IP addresses. So these instances that I'm showing here in the upper left, you would enable ClassicLink, and you would link these instances into this VPC, and I'll show you how that API is going to look here in a moment. And then these instances will be able to access your VPC resources subject to all of the normal VPC security group rules. So you'll be able to consider these as just members of your VPC security group. Now, I should be clear that these instances will not be full VPC instances. So they will not have an ENI, and you will still, with this approach, you will still need to essentially launch replacement instances. But during the migration, you'll be able to have this bidirectional private IP communication with VPC and Classic. All right, so here I'm showing just that. I'm showing that now I've launched some new instances in my VPC, and I've created a new load balancer in my VPC. And all of these are able to talk to the database, which is running in VPC now. And then I can use DNS to start to shift traffic from my Classic environment over to my VPC environment. And in fact, the load balancer here running in VPC will actually be able to use the Classic instances as backends for that load balancer. So in some cases, you don't even need to launch double capacity. You wouldn't need to launch twice as much capacity. You could actually do it sort of instance by instance and slowly migrate your instances from Classic into VPC. I should note that doing this, you are going to be redirecting DNS to a new set of IP addresses. Today, Classic and VPC IP addresses are separate pools. So the Classic IP addresses the EIPs that you would use would be replaced by the VPC EIPs and updated through DNS to direct traffic towards the VPC load balancer. All right, and then once we've completed that part of the migration, we can then turn off and remove our Classic infrastructure, and now we're running in a VPC-only mode. So the overall approach with ClassicLink, I'll show you some APIs in the next few slides where you'll be able to enable ClassicLink for the VPC. You'll create the VPC security groups, just as you have done before. Start to deploy in VPC. Add those Classic instances into the VPC security groups, and then begin the component-by-component migration. So we built this feature. ClassicLink is built to be, again, highly available. The capability here introduces no additional intermediate between the instances. So the instance-to-instance communication between Classic and VPC will be just as it is for other instances within our network. There's no additional intermediate there. And so it's high capacity as well. All right, so I mentioned earlier about AWS managed infrastructure. I wanted to share just a bit more of a clear picture of that. So here I show on the top left, I have my EC2 Classic infrastructure, my instances. And then on the right-hand side, I have the AWS managed infrastructure that I use in Classic. So that would be RDS databases, ELBs, Elasticache nodes, Redshift databases, and the like. When I moved to VPC, that's one of the main differences when we move to VPC is that although it is still AWS managed, it does show up in your VPC as Elastic Network Interfaces. So in your VPC, you will have an ENI for your RDS database or for your ELB and so on. So with ClassicLink, the top green arrow shows the existing pathway that you'd be using in Classic. You have connectivity between your instances and the AWS managed infrastructure. With ClassicLink, we're going to allow this new green path where your Classic instances can talk to anything that's running in your VPC. The red arrow, though, is meant to show that the AWS managed infrastructure will not be able to communicate directly with other things in your VPC because it is AWS managed and it doesn't have access to the ClassicLink capability, which is account-centric. So that's why we recommend essentially starting with AWS managed infrastructure, get that set up in your VPC, then move on to load balancers and then the backends that are behind those load balancers. All right, a few other considerations to use. When you create the VPC that you're going to use with ClassicLink, it needs to be either in 10.0/15 or any other range outside of 10/8. And the reason for that is basically that all classic EC2 instances are in the 10.2 to 10.255 range. And so for ClassicLink to work, we actually need to have access to that whole range to talk to your VPC. So make sure that your VPC is addressed accordingly. We also have a rule in place to prevent you from accidentally creating a black hole topology where if you have a route table entry to 10/8, you won't be able to use ClassicLink as well because, again, the classic instances are in that 10/8 range. Now, what customers can certainly do is create a VPC, use ClassicLink, complete a migration, and then all of these rules go away as far as the routing table issues are concerned. You can then create a 10/8 after ClassicLink is turned off. You know, once you turn ClassicLink off, at the end of your migration, 10/8 is available in the route table. All of the classic, the classic instances that are classic linked will still be classic instances. They don't use the internet connectivity through VPC. They also don't have access to VPN or Direct Connect through the VPC. So again, it is instance to instance private communication between VPC and Classic. That's what the feature enables. And you will be using this, you will enable ClassicLink after you run or start an instance. So whenever you do one of those operations, you will need to complete the linking process to enable the communication. And finally, there's a caveat about DNS names. DNS names the private names will not resolve across this link either, so you'll use IP addresses to communicate between Classic and VPC. All right, so now I'm going to give just a brief summary of the APIs of how it's going to work. So there will be a total of 4 APIs in use here. There's also a describe API as well that you'll be able to use. But again, to start, you'll enable ClassicLink on your VPC. And again, this is to allow you to have an IAM policy. If you don't want to have anything to do with ClassicLink, you can lock that off with IAM, and it won't impact your VPC in any way. But you'll be able to enable it. You will then call this attach ClassicLink VPC function, and this is where you'll specify the instance ID and the VPC and the security groups that the instance will now belong to. So again, these security groups will be VPC security groups. And you will have the ability to detach or disable as well, so that once you're complete, you'll be able to turn it off. A couple other considerations to talk about with other services. So again, I mentioned on a previous slide, but EC2 Classic instances through ClassicLink, you can use them as backends of VPC load balancers. So you can actually go today, in December, assume today is December, you will be able to create a VPC load balancer, Elastic load balancer, and then wire in your EC2 Classic instances as backends for that. You'll also be able to use this with spot instances, as well as auto-scaling will be enhanced to support linking Classic instances following launch. All right, and that concludes my update today on sort of VPC routing features and our ClassicLink feature. I can't take questions now, but I will step outside and be available for questions. Thank you very much for coming.